Hi everyone, welcome to this exciting World Space Week talk show series on AADYA GEO TALKS, where we are going to explore the role of geology in space science and India's space exploration programs. I am your host Bharti Sharma, geologist and founder of AADYA Planetary and Geoscience Research, a trailblazer in the field of geotourism and collaborative research, a startup that deals in geology field training, geoconsultancy, and skill development. And today I am privileged to share my screen with Dr. Binita Phartiyal Ma'am, a great mentor one could ever ask for. She's a pioneer in paleoclimatology and quaternary geology of the cold deserts of the world. She's the first Indian woman to set foot on both the poles. She has worked in Antarctica, the Arctic, and the Himalayas, especially the Trans-Himalayan sector, the Ladakh one. She is presently working as a scientist F at the Birbal Sahni Institute of Palaeosciences in Lucknow. Thank you so much, ma'am, for giving me this honor today.
Thank you,
Welcome to
Bharti,
Adya
for
Geo Talks.
having me in this show. Thank you so much.
So, ma'am, to begin our conversation, should we go back to your early career research days? What was the eureka moment that made you realize that this is it, this is my field?
Yeah, okay. Nice question to begin with. And firstly, Bharti, I would like to thank you for having me here, and I would like to congratulate and salute you for your effort of the startup Adya that
Thank you,
has
ma'am.
a very focused objective of taking in the planetary and the geological sciences ahead, and you are doing a commendable job. Thank you for that. Coming to the question that you said, that what was my first step in geology, I think I should give 100% credit to my teachers in geology at the bachelor's and my master's levels. I was lucky to be taught by teachers like Padma Bhushan, Professor K.S. Waldia, and the entire faculty that we had at that time. When I was in college in the early 90s at Kumaon University in Nainital, it was a very apt blend for me to be attracted to the subject and study it further for my PhD and then make a career in it. And before geology came as a formal subject for me, I was born and brought up in Nainital, and it's a hill station in the Himalaya. And so I was like very close to nature in my early days, to the mountains. I loved the mountains, the shapes, the landforms, and it really attracted me. So I was always passionate about these mountain ranges, and the entire credit goes to my father, who was an advocate by profession. He was a man of simple living, high thinking,
Okay.
and he was more of a naturalist. He used to take us for nature walks every Sunday. Every Sunday, we were like climbing some hill, going through these mountain trails. So I have some very fond memories of those talks with my brother, little brother, and later, when my sister also was grown up. So all three of us and my dad, we used to be there. And going through these trails through the mountains, we used to discuss on every subject that or everything that we saw, whether it would be a small rock piece, a beautiful one, some weathered rock piece, or some rock with a little vein in it. At that time we really didn't know much about it, but the different collection of rock, and not only rocks but the vegetation, the green, we had a whole pack of things that rocks and these green leaves when we came back home, for the herbarium, for putting it in the vases in the drawing room, and so on. So like nowadays people go for shopping, and they have these shopping bags, and during that time we had all this collection of rocks and these green vegetation in the of the hills. So a question, it always triggered whenever I was on top of a peak, or seeing the ranges after ranges. So I was always mesmerized by the beauty of those mountain ranges. And I always used to think what would be beyond that. And that led to my me to explore the lesser Himalayas where I was in, then the higher Himalayas, and then the Trans Himalayas. Then later, my collaborations with the Tibetan Plateau Research Institute in China, and now beyond our planet. So I'm venturing into planetary geology researches. It's new for me also. So the journey of geology started for me, and it goes on till today.
So you started your geology field training in your like childhood, not in your early career research days, but in your childhood. That is so great,
True,
ma'am.
true. Yeah.
So, from your perspective, how does geology intersect and contribute to the field of space science, especially when it comes to planetary exploration?
Okay, so I've been associated with the Indian astrogeology group since 2016, and there we were looking up for the analog sites and studying them for the landscape evolution and habitation. So, planetary exploration and geology, how do they link or intersect? I would say that it goes to the beginning of the formation of the Earth. We all know that according to the solar nebula theory,
Mm.
that the Earth and the other planets in the solar system, they were formed about some 4.5 billion years ago by the condensation of interplanetary dust, meaning to say that the basic ingredient or the basic constituent of all the planets is the same. Okay,
Mm.
so we know that the primordial Earth, which was hostile environment, it had a thin primitive crust, abundant volcanic activities, and extraterrestrial impacts also at times. So since that time, the evolutionary history, the Earth has evolved from a very chaotic system to a relatively gentle modern world, which is capable of supporting such diverse ecosystems as we see today. Well, it's not yet static, it's still active.
Mm.
And how do we know all this? We know all this by studying these rock formation, the rock strata that is on the Earth, that is in our country, right from pre-Cambrian, the oldest rocks,
Rocks.
to Quaternary, the Holocene, now the Anthropocene. So, so geology has been the base. So
Mm.
and then when the evolution was going on, so we know about these catastrophic mass times that when mass extinction happened. So that is also very well recorded in the geological record. So, and this revolution in the studies in geology and linking it to the universe, it all happened in the 20th century when the Earth scientists, they brought into existence several powerful concepts that modified and that expanded our view of the universe. So, in
Mm.
almost all fields of sciences, they have gathered enough evidence to claim that our world is more complex, it's varied and interconnected than it was previously supposed. So, if you go back to history, in the 14th and the 15th century, even in the 15th and the 16th century, times of Copernicus and Galileo Galilei. So
Mm.
we were thinking that the Earth is the center of the universe.
Universe.
Yeah. So
Mm.
only after that our concept developed, and so it's very recently that we got aware that how minutely a big neighbor, which is the universe itself, has affected the Earth's processes, including life and climate. So these theories like the plate tectonics, like the planetary geology, like paleoclimatology, they are some forefront subjects in geology today. So geology does not only intersect, but its understanding provides a baseline
That's one.
for all the planetary studies. So, if I can put it in other words, it could be planetary exploration in the context of geological and geomorphological researches
Mm.
can be explicitly understood and well interpreted only if the processes on the terrestrial surface of a planet Earth are well studied and understood. So geology is the base of the planetary studies or exploration, you can say.
So, to understand the other worlds, we should understand our own Earth better, and that will help us understand the other celestial bodies.
Yeah,
And geology is the base for every science. Though it is an applied science, but it is the base for every science.
true, true, true.
Ma'am, you have made significant contributions to the geology of Ladakh. Would you want to convey why Ladakh is the ideal site to study Martian geology?
Yeah, sure. In India, there are several sites.
Mm,
There you can list them, like you have, which can be listed as Mars analog sites. Like
mm,
you have the arid west, the Run of Kutch, the saline. For miles, you just see the salt and marshes. Then you have the Meghalayan caves. I was just in Shillong, and we visited some of the caves. Then you have these mines that go deep into the earth crust. So the bacterial activity there can
right.
throw light on the Martian life. Then you have the coastal region, and we also have the ocean on the three sides of our Indian subcontinent.
Mhm,
But Ladakh, why Ladakh is the main reason. So Ladakh, as you know, it is the western edge of the Tibetan Plateau. It is a barren, cold altitude desert, and it has a lunar topography. The early papers that we read from Ladakh when we were starting our work in the year 2000. I visited Ladakh for the first time. So there's a place called Moonland. So we
mm,
went there, and the papers had also mentioned this place as Moonland, not as Lamayuru. So today, the Lamayuru, locally, it's called the Moonland,
yeah.
just because the topography, the geomorphology of that place was so much like the moon. It did not resemble anything on the earth.
Mm,
So Ladakh is a place that has some features of the best sites to study astrogeology because of the extreme cold. Now, what happens in the cold times, that physical weathering takes place. So that lots of shattered material is there,
mhm,
and the debris is there. Then it is because it is high altitude, so it is above the tree line, so hardly any vegetation is there. So these are barren slopes. Then it has a desertic kind of environment. So all these features and the place that Ladakh has, so it makes it a very good Mars analog. And when we look at these or read the papers on the researches of Mars, they point to that Mars also has cratered highlands. They are of moderate and high relief. Mars has rugged mountainous material, knobs and massives there, and it also has extensive tracks and channeled plains. It has superficial deposits and
mhm,
features like pebbles, cobbles, conglomerates, and even outflow channel systems are reported from Mars. Then frozen ground, etc.
mm,
So
awesome.
all these features that till now we have in Mars, they are suggestive of what? They're suggestive of mass movements. They're suggestive of landslides.
Mhm,
They are suggestive of catastrophic floods. They're suggestive of active fluvial processes
mhm,
once upon a time. Then erosional and depositional work of the wind, water, ice. Yeah,
mhm,
and even we have papers which say that there is high silica in the rock, which implies that the parent material was differentiated. So the Earth's surface processes, they can build a strong upsurge of interest. Yeah. So geologists and geomorphologists can make significant contributions to space exploration, whether it's the Mars or the Moon, or because of their background and their experience with the earthy forms, the constituent and the processes that we are studying in this Ladakh. And in Ladakh, the beauty is that it has all in one place. Yeah.
Yes,
So
indeed.
you were there, yeah, you were there in that with us in that expedition. So you
Mhm.
know well that we see saline lakes, we see freshwater lakes, we
Lakes,
see the permafrost, we
frost.
see the cryosphere, the glaciers in our. We see the hot springs, which are easy to study the extremophiles, whether they are
Mhm.
halophiles, whether they are thermophiles or psychophiles, which can tell us about the ancient life in Mars.
Mhm.
Then secondly, the region, Ladakh region, has all types of rocks that are exposed there. We have the igneous rocks, we have the sedimentary rocks, we have the metamorphic rocks. Yeah, so the igneous rocks, they are both plutonic, that the Ladakh batholith, yes, the big massive batholith emplacement of
Metal.
granite and granodiorite, and
Mhm.
then we have the volcanic rocks,
Rocks.
Dras, which is in the western side of
The
Ladakh's
Kargil sector.
near the Kargil. Then we have the Khardung volcanics.
Mhm.
So these are the igneous rocks. Then for the sedimentaries, we have the entire Tethan Himalayan range where we have these sedimentary rocks. Then we the metamorphic rocks, they're exposed in the eastern side of Ladakh, the Pangong So range. So basically, what I'm saying, that it is a concoction of all good geology and landforms. So it makes it a very good site to study to be analog for Mars. So the geographical setup, the dynamic and the active geological setting of this is a very young mountain chain, the
Chain.
Himalaya, the entire Himalaya, and the science capability of especially this Ladakh sector. It supports the astrogeology as well as the astrobiology
Biology.
studies. And thirdly, for a place to be an analog, you have to do a fidelity check, like
Mhm.
whether it has a fidelity for being an analog. What is its geomorphological fidelity? What is its geochemical fidelity? What is
Mhm.
its exobiological fidelity? So Ladakh fits in all.
On all.
As far as geomorphological fidelity for is concerned, Ladakh is dry, it's cold, it has abundant rocky ground, and dust devils are there.
There. Mhm.
There are wide river valleys where fine material is coming, and then the wind speed is so high, so it picks this up, and there are dust devils all around, especially
Mhm.
after 2 p.m. in the Ladakh area. It's very hard to just stand while doing field works. Many times, my cap used to just fly and
I
get
totally related.
so many of them. Yeah, then later I used to get the one with a sling and tie it. so
Mhm.
so there is a lot of loose rock that's blanketing the slopes.
Mhm.
So there is permafrost. Yeah, we have rock glaciers that we saw in Sokar also. We have
Mhm.
sand dunes of Hundar, and
Mhm.
the beautiful drainage network of the mighty Indus is there. So the geomorphological fidelity is like 100%
Percent.
for studying it as a Mars analog. Coming to the geochemical fidelity, as I said, you have all types of rocks. Quartz is there, granites, so you can study the volcanic
Mhm.
rocks.
Rocks.
So the geochemists are studying that. And as far as exobiological fidelity is concerned, we have the permafrost, as I just mentioned, which is the evidence of water in the past. And then there is increased UV and cosmic radiation flux. Uh, it's the atmosphere is very, atmospheric pressure is reduced.
Reduced.
There are several hot springs around which are rich in sulfur, which are rich in boron. So Ladakh, it is the best site to be analog of Mars in India.
Yes, indeed. So Ladakh has everything to offer.
True.
So,
And
Ma'am, students come up to me for like when they want to go for their PhD or their MSc internships. So they always come up how we can get associated in Indian labs and such sort of things. So, what are the primary research questions that your lab is currently addressing, and how they are related to planetary geology? It's for the students who wants to do internship with you or who wants to do PhD with you.
Okay, okay. Yeah, this is a nice question, especially for students who really want to pursue this, geology and planetary geology together. So, as I previously stated that, I too am very young in this field.
Yeah.
We started in 2016 when I was a member of the NASA Space Bound India program. And since then, we've started this work in our institute. So basically, my group, it works on the surface processes, especially the glacial, the fluvial, and the lacustrine processes and the landforms there, and also on the past landform reconstruction and the past climate reconstruction with reference to chronology. As I said, Himalaya is a very dynamic system,
Yes.
so the landforms also, they really, like today you could see a river channel in the area, but few thousand years ago there would be a big lake there. So this has really changed fast in the term of, the geological past. Yeah.
Past.
So what we do is we study these, and our studies, they throw light on the textural and the facies analysis, on the surface processes, on differential weathering and rates in respect to time in this arid environment. And so all this, it helps us better understand the processes in the Martian surface. Yeah.
Yes.
And then we know that in Mars, we have these long lasting hydrological cycles that are reported. So our studies in the fluvial systems of Ladakh, and the lake systems, they help us in understanding the cycles in the hydrological cycles in the Mars better. So this is the work that we are doing, and we also do multi-proxy studies on the sediments of in the permafrost zones. So in Ladakh, you have this permafrost there. It's found at about 80 centimeters or 1 meter. So we've started working on these permafrost zones by studying the microbes and what is the characteristics of that, and how deep is it, and how is it placed. So we want to understand the extreme environments, and this again, in turn, it helps us to understand the exoplanets, or understand Mars. Lately, we got interested in this. DOM study. DOM is basically dissolved organic material.
Material.
So it shields organisms from the UV effects. And in the context of the global warming, there are a lot of lakes now in the Ladakh range. These are freshwater lakes because the snow and the glaciers have melted or retreated. So they leave these glacial lakes all there, and they are rich in their biota. They have their own niche and ecology. So we want to start this DOM study, which is a natural sunscreen, as I said. So it is influenced by the water transparency, and it determines the photic zone depth. So these studies have been done in the alpine region and elsewhere, but above 4,000 meters, like Ladakh is a high altitude desert. So the altitudes that I'm talking about here are above 4,000, 5,000, 6,000, ranging till 7,000 meters. So this is the work that we are planning to take up, and we would observe these lakes and the evolution of these lakes and the microorganisms in these lakes. So the survival strategies of these microorganisms in this lake might prove to be ancient. It could give us a peep into the Earth's past, and it could have a resemblance to the Martian paleolakes at the end of the Noachian era, that is about 3.5 billion years. So this will allow us to test the habitability potential of the water uh, uh, on early Mars, and to prepare for the future
Future.
astrobiological missions. So these are the works that my group is doing. And other groups in my institute at Birbal Sahni Institute of Paleosciences, like there is this pre-Cambrian paleobiology group. So they are working with the very old rocks
Mm-hmm.
of the oldest, Precambrian is the oldest rocks from 4,600 to 540 million years. So they are studying those rocks and they're trying to see that was the time, when life was in a unicellular form.
Cellular
So
form.
they are trying to, work on that. So that is also one of the study that students can pursue in our institute if they are interested.
Okay, so students, please note down that there are abundant opportunities at Birbal Sahni Institute of Paleosciences. To wrap up our discussion, what takeaway message would you like to give to the future geologists to remember and carry with them with their journey in their journey ahead?
I would say there is a, a lot of scope in the subject, and this is a time for multidisciplinary studies where scientists from all disciplines are working for a common objective, that is planetary sciences. So, whether you are a geologist or a chemistry person or a biologist or an engineering person, robotics person, we all can connect together with planetary geology, planetary sciences. And you should have a very very thorough knowledge of your subject, like if we are like all of you are geology with geology background here. So that would really help you, but at the same time you should understand, the other processes, the chemical processes or the biological biotic processes that are going around in the systems that you are studying geology. So there is a lot of scope in this subject. So you should be very strong, you should be focused, and you should be very thorough with things, do them with enthusiasm.
Yes,
You should study earth science, because earth science or geology is a field science, and trust me, the field moments are the best moments of your
yes,
life. I've done
indeed.
so many fields in Antarctica, in Arctic. It has taken me to several, places where you are just mesmerized and where it's like no man's land. It's, to you. So you would really love those field moments. Although it may, seem tough when you're there for months. It would be isolated. You would feel dejected, but you should not lose focus. Those are the testing times.
Yes.
So the message is pursue geology, pursue earth sciences, and take it ahead to explore the planetary geology and contribute to the planetary science. Because till now we've done a very minuscule part of
Part
it,
of it.
we're just starting. It's a first step. So students, you students are the ones who have to take it further and, establish facts and theories about what may be in Mars or what may be in the other planets
Planet.
yet to explore. So I wish you all the best, all the students here. So that is my message to all of you.
So, students, geology is not a dying field. It is currently a new field when it comes to planetary geology or global warming or climate change. And geology provides a base to all these sciences, as we all geologists believe, and it is true indeed. And yes, I can't agree more on the field movements with Binita ma'am that I have traveled so much only because of my field trips,
True.
and it's the best part when it comes to studying geology. So, as we conclude this enlightening conversation, I would like to thank our esteemed guest, Dr. Binita ma'am. Thank you for sharing all the insights and expertise, ma'am. Thank you so much
Thank
for coming
you,
here.
Bharti.
And as we
Thank
always say,
you.
conversations don't end here. So keep exploring and follow us on social media. And you can text ma'am, you can text us to know about planetary geology and their opportunities in India. So keep striving for the stars and explore the mysteries of the cosmos. Thank you. Namaste.
Namaste. Thank you, Bharti. Thank you. Thank you all.
Thank you,
Bye.
ma'am. Bye.